Hello everyone. Today we are going to learn about variables and what the little tilde means next to certain parts in the and it should look like this when it opens, and there's a whole bunch of stuff here. So what I am going to do is I'm going to uh, get rid of some stuff, and we're going to put this is called an oscilloscope. We're going to put the oscilloscope off to the side for a little bit because that doesn't come in until a little bit later, and we're going to build the circuit without the breadboard. So I've already changed this resistance to 220 ohms. I believe, starts at 1 kilo ohm, but I like 220, and I use R on my keyboard to rotate it. And let's zoom in a little bit. So take my cathode, connect it to the ground, and then I'm going to go to pin 9, and I'll connect that to the anode. And so power, once I tell the Arduino what to do, power will come up the pin 9, go into the anode, go through the LED, out the cathode, through my 220 ohm resistor, and the ground, that's home. So there it is. Now, what I'd like to point out is, so this is the digital side of the Arduino. There's also analog down here and power down here. We are not using those. We're just going to go straight digital, baby. And if we look at these pins, we notice that 0, 1, and 2, and then when we get to 3, there's a tilde. And tilde is this, oops, that's not what I meant. Tilde is this shape right here. There's a tilde only with certain pins. So 3 has the tilde, 5 and 6 have tildes, and then 9 through 11 have tildes. And that has to do with the pulse width modulation. What? The PWM. Well, that didn't help either. We'll find out about that for a bit. But what you need to know is that we could not build this with pin 8. And the reason we can't do it with pin 8 is because it doesn't have a tilde. So we cannot make this LED get brighter, 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 darker, darker, darker on pin 8 or 7 because they don't have a tilde. It only works with tilde ports. And I'll show you that in a bit. This is ultimately what we're hoping for, this little video right here, where the LED gets brighter and brighter and then darker and darker. It kind of oscillates through brightnesses on its way up and down. Let's click next. Okay, build the circuit. You already did. Yay! Comes pre-made. Lucky you. Build the brightness code. So now what we're going to do is we're going to look at coding. So we have it all powered up, as in we've built the circuit physically with all the physical components, the LED and the resistor and wires. Now we have to tell the Arduino to do stuff. So if we click on code, you get this stuff. This is all pre-made. We could have coded it ourselves, and we will later. And this is called block code. So this uses blocks, which come in all these different flavors, which we've already talked about. And what I want to talk most about here, is the comment just tells you that it's going to fade in and out. And this idea of brightness. So what brightness is it's a variable, right? Brightness is just a number. And it says, if we look, there we go. If we look at the code, it is a number that's going to start at 0 and climb up to 255. Now, that may seem odd. Why is it from 0 to 255? And the reason is powers of 2. Wait, what? Turns out that if you have 8 bits of information, then you have 256 different possible combinations. So the values can go from either 1 to 256, or computers already always start at 0. So it's 0 to 255. And you don't need to know that, but if you do powers of 2, so if I multiply 2 by itself 8 times, or 1 bit, you get 2, then 2 times 2 is 4, so that's to the second power, then 8 to the third power, 16 to the fourth power, 32 to the fifth power, 64 to the sixth power, 128 2 to the seventh power, 256 2 to the eighth power. And since computers can only go off and on, which means for each wire there's only 2 possible values, off and on, if you have 8 wires, then there are 8 offs and ons. And that gives you 2 options, 8 different positions, 2 to the 8th power, 256. So what we're going to do is we're going to rifle through the values from 0 to 256, but we're going to increase by the number 5. So when we first start, brightness, the variable brightness, which is like x in math or y in math, and the variable brightness will start with the value 0. And then once it goes through this loop, it'll increment by 5, and brightness will equal 5. And then it'll go through this loop and increment by 5 and be 10. Then it'll go through this loop and become 15. Go through this loop, 20, then 25, 30, 35, 40, 45, all the way up to 255. And when it hits 255, it'll stop that piece of code here. This piece of code from count, this little piece of code here. Okay, so what happens as brightness goes from 0 to 255, incrementing by 5s? Well, we set pin 9 to brightness. Now, if I click on this, these are all the pins I can set to brightness. That's weird. It's only 3, 5 and 6, 9, 10, and 11. Why is that? Hey, 3, 5 and 6, 9, 10, and 11, those are the ports with the tilde. Look at that, it even stayed up because my computer's amazing, right? These are the ones where you can actually muck with seemingly the voltage, and we'll talk about what it is, but you can't do this with pin 8. Pin 8 isn't even an option here as we look. You can only do it with the tilde values, and there's a reason for that. So we're going to choose 9. There's a reason for that, and we'll talk about that in a bit. And then we wait 30 milliseconds before we increment brightness by 5 again. So we start at 0, set pin to that value of 0, wait 30 milliseconds, go to 5, set pin to 5, wait 30 milliseconds, 10, set pin to 9 to 10, 15, set 9 to 15, 20, 25, 30, 35, 40, 45, 50. So each time brightness increments, we set pin 9 to that value between 0 and 255. And, well, what does that look like? It looks a lot like this. Hey, it gets brighter, and then it gets darker. It gets brighter, and then it gets darker. It gets brighter, and then it gets darker. So let's move this over a little bit so we can see the code. And this bit right here increments, goes up by 5. This is the part of code that makes it brighter. And then this does the exact same thing, but it goes down. So this makes it darker. So what happens is we go through this 0, 5, 10, 15, 20, 25, 30, all the way up, setting pin 9 to these new values as brightness changes. And then when it hits 255, we click out of this loop and hit this loop. And down here, we start at 255 and count down to 0. So this is going to make brightness decrease in value from 255 down, and we just set pin 9 to that. So 255, then 250, then 245, 240, 235, 230, 225, all the way down till we hit 0, and then we come back up here, increase brightness, then we come down here, decrease brightness, and that's what we're watching over here. But to really get it, what we need to do is not look at the block code, but look at the text. So if I do the block drop-down menu and move over to block and text, this is what the computer actually reads. This is the entire code. So this block that's just for people who are new to coding, and it's a more visual way to code, kind of see what's going on. The computer actually doesn't read this at all. The computer only reads this. So if I change things here, like right here, it says wait 30 milliseconds. So this first loop is right here. Oops. This loop right here is right here. This second loop is down here. And what I mean by that is brightness starts at 0. Oh yeah, I saw that. Goes up to 255 and it increments. And it increments by 5. Once I get my cursor over there. By 5. So this line says start brightness at 0, stop when it's at 255, and increment by 5. And then do this, analog write. Now that is a function that was built by somebody when they made an Arduino. The people who came up with Arduinos and built them wrote a function for us called analog write. And if we pass in a value between 0 and 255, analog write will set a pin that we give to them, so this says pin 9, to that value. So if I change, let's say I change, instead of wait 30 milliseconds, I say 300 milliseconds. You'll notice the delay just changed. And if I change it back to 30 milliseconds, it changes. So every time I change one of these blocks, the computer changes this text code, and this is what the computer actually runs. The computer does not see this at all. It only sees this, right? So, and if I change the set pin to 10, now pin is 10. And you'll also notice that, hey, wait, that's weird. This popped up. It says, if I set this back to 9, as I go through this code, I notice it looks different here. And if I set it to 10, 10 pops up here. So now let's look at this code from top to bottom. Okay, this right here, this is called a comment, and that's just for the humans. Computer skips right over, and that's why it's a different color. It tells the humans the computers don't even read it. Here's our variable brightness. We started at 0. Oh yeah, we talked about that. This section of code sets up the Arduino. And what this says is, hey, pin 9, I'm going to use you. Somewhere down below in the code, you are going to be activated. So let's wake you up. And that's what pin mode does. It just kind of wakes up the pin. So if I change this to 10, then I have to wake up 10 and 9. But we don't use pin 10, we just use pin 9, so I'll get rid of that. So pin mode just wakes up the pin, the correct pin, the plug that we're going to plug our circuit into, and then we start at 0, we go to 255, we increment by 5, we set 9 to whatever that value is, and then we wait. And when that finishes, we do the same thing backwards, where we start at 255 and we go down to 0. And then we set pin 9 to that value and wait. And rifle all the way down to 0, and then we loop back up. Okay, so that's what the code looks like. And that's what it does. Woo! Look at that. So counting brightness up, then counting brightness down, then counting brightness up, then counting brightness down. Okay. That's what all this stuff says. Okay, now let's explain it. It is all about analog write, baby. That is a function that's pre-written. I didn't code it. Came with the Arduino. It takes 2 arguments. The pin number, which is 9. So if I look at the code, again, analog write takes pin 9. If I change this to 10, right? If I change this to 10, then pin 10 would do this. Now, what would happen if I hit go right now? Pin 10 is going to get brighter, but nothing's connected to pin 10. So the LED will not light up. Oh, wait. Actually, I don't know why the LED lit up there. Oh, so it just, that's, sorry. It doesn't get brighter, but it will get darker because we use pin 9 here. So if I set both of these to pin 10, then you notice only pin 10 gets set up. It'll get brighter and darker there. And now, if I hit start simulation, nothing happens until I move this to pin 10. And now we get the same action, but on pin 10. And why does it work on pin 10? Because I changed these to pin 10. Okay, but how does this really work? How does analog write really function? What do you mean I can only use it with tilde, ports that have tilde, and is it really changing the values? And the answer is no. By the way, this one, this page just says that if you go to components and go to starters, the Arduino, the fade one is right here. So you could just start with, this circuit just straight out the gates. These are all the pre-made ones. So you may have a Arduino circuit that you want to build that's based off of a pretty basic one. So you can just drop that in and then edit it as you see fit. But this is where we get into pulse width modulation. Woo! What's pulse width modulation? Well, to understand pulse width modulation, we need to get that oscilloscope kicking. What an oscilloscope is literally a graph. That's it. So if I look at an oscilloscope, I see a line here. That is more or less 0 on time. And I see a line here, and that is 0 on voltage. So as time passes, I can watch voltage change. And we need to hook it up. So let's put the positive on the positive and the negative on the negative. Oh, missed. Hit. That's ugly. Do it again. And now I can actually see the electricity that's going through the LED, because as it comes up here, some is going to go into the anode and go into the LED, and some is going to go into this oscilloscope, and the oscilloscope is going to show us what kind of power the LED is getting. So let's hit start simulation and see what's happening. Wait, what craziness is this? What is that? That is pulse width modulation. So one of these humps is called a pulse. And they are getting wider and thinner. So the width of the pulse is modulating. It is changing. That's what pulse width modulation means. Now, here's the problem with Arduinos. And you'll notice that when they're thin, this is darker. And when the pulses are wide, when it has big wide teeth, it's brighter. When it has thin, tiny little like stick teeth, it gets darker. Now, what this means is, what you're really looking at is the voltage. Now, here's the problem. Arduinos can only turn off and on. So how do you get like medium light? I mean, it's like a light switch, right? How do faders work? That kind of thing. How do you get that medium light? Well, the way the Arduino does it is it actually is turning on the LED every moment that it has voltage. So what that means is when the line is up here, the LED is on. And this is as time goes by. So it's drawing this really fast. In fact, if we click on it, it says that it's drawing it every 1 millisecond. So thousandth of a second is what it's drawing. And what is actually happening if we had better eyes, if we weren't humans, but were some sort of animal that could see milliseconds, then first thing, movies wouldn't work anymore. Sorry, movies would look like stop motion animation to you. And two is we would actually see this LED turn, and let's zoom in. We would actually see this flickering on and off really quickly like a strobe light. But we can't see that. So what's really happening is it's turning on for some amount of time and then turning off for some amount of time, then turning on for some amount of time and off for some amount of time. And the longer it's on, the brighter it looks to us. And then the longer that it is off, the darker it looks to us. So this isn't really making it lighter or darker, it's just lighting it for longer and shorter periods of time. So as it brightens, what it's really doing is just leaving the power on for longer. And it looks to us, our human eyes, as if it's getting brighter and brighter. And as it gets darker and darker, what it's actually doing is turning it off for longer and longer segments. And we see it as darker and darker, but it's actually just off longer and longer. What is happening is a huge strobe effect. It's actually turning off and on really quickly. So that's what all this is saying. And that can only happen with 3, 5, and 6, 9, 10, and 11. Those are the only ones where analog write works. So if I tried this with 12, it wouldn't be able to turn the pin on and off for short periods of time. It would either turn it on or turn it off. And then this talks about how you can make your own if you have an Arduino. And now it's saying, hey, what if you kind of messed with this? What if, and let's get this guy out of there because that's kind of distracting. What if instead of an LED, what if you did, oh, that's right. Oops, sorry. I forgot I left it in Arduinos. Let's go back to components and let's search LEDs and components, LED. And what if I take this guy? Now let's put him front and center. Now this is the cathode is the way out, so I have to attach that to here. And let's see, I've got a red pin, I got a blue pin, I got a green pin. What if I connect, I don't know, blue to 10? What happens then? Oh, it's that same kind of idea, right? It goes on and off, right? But what if I take green and add it to 9, and let's color it green. I forget. There we go. Green to 9. Now, right now, we never talked to pin 9, so there wouldn't be any green happening here, right? But if I open the code, and here's the nice thing. Let's go back to just block. Let's make it a little easier to look at. If I click here, if I right-click here, I can duplicate that entire block. And so if I put it, I don't know, way down here at the very bottom. So these top two increase brightness on pin 10. And if I go down here, I can change it over to pin 9. And now, these loops that I wrote before, the increase pin 10, then decrease pin 10, I now have increasing pin 9 and decreasing pin 9. So what should happen is, it should go, because this is pin 10, it should first go blue, 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 darker, darker, then lighter, lighter, blue, 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 and then it should switch over to pin 9 and go green, 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 green. Let's see if that works. There's my blue, my pin 10 counts up, my pin 10 counts down, my pin 9 counts up, my pin 9 counts down. Ooh, isn't that fun? And that's a bit of your homework. Your homework is, please set it up so that this cycles through red, blue, and green colors. So one LED RGB cycles through red, blue, and green colors. Oh, I should have, sorry, I should have, where's the blue? There's the blue. Should have made that a blue wire, I realize. I don't know how to do that. Well, use tilde, only tilde ports, and copy the code like I just did. I wish you luck.